This is a recording for Section 8.5, Annuities, Methods of Saving and Investments. So far, when we dealt with the formulas 3 and 4 on the formula sheet, it was only a one-time investment or one-time borrowing of a certain amount. Whereas the term annuity is a sequence of equal payments made at equal time periods. The value of an annuity is the sum of all the deposits plus the interest paid. So what you will see that there's a savings formula for annuities, and it's formula number 5 on the formula sheet, and it has the same variables, the P, R, N, and T, and A, as the regular compound period formula. You just really need to watch if it's an annuity. If it tells you you're investing $50 a year, that's annuity. Otherwise, if it says if you invest $50, how much do you have at the end of the time, you're doing a one-time investment. That's the formulas 3 and 4 that we dealt with in the last section. The thing that you're going to have to watch for, especially when you're doing your homework, is the verbiage at the end of the problem telling you how to round. When calculating annuities, pay special attention to the directions in blue after your homework questions. For example, if you get something like this out and it tells you to round up to the nearest dollar, you would actually make it 1,433. Even though if you round to the nearest dollar, we know that this is, the number after the ones place is less than 5, so we would round it to 1432. But sometimes it says round up to the nearest dollar, so you would just round up no matter what. Otherwise, it might say round to the nearest cent, and then of course it would be 1432.12. All right, because the number after the 1 is larger than 5. So just pay attention to how it asks you to round in MyLabs Plus. So suppose you deposit $1,000 into a savings plan at the end of each year for 3 years. This tells you right now that it is an annuity because it's multiple deposits. The interest rate is 8% per year compounded annually. Find the value of the annuity after 3 years and find the interest. We're first just going to show you how you would do it without the formula number 5. So you invest $1,000, right? And at the end of the next year, you would, if you use the regular compound interest formula, the P times 1 plus R over N to the NT, you were just doing it for 1 year, so this here is 1, right? And if you find this amount, that's telling you that at the end of the year, you've made $80 in interest, so you have $1,080 in there, but you're going to add another $1,000 in there because you're putting in $1,000 at the end of every year. So now you have $2,080. So at the end of the 3rd year, you can do your P times 1 plus R over N to the NT again. It's just these are 1. Your basic compound interest formula, and you'll get 2246. So that's the amount on the $2,000 you've invested so far, plus the interest. Right, and then you add another 1,000, so that the value of the annuity at the end of the 3 years is $3,246.40, and you can see that we've put in $3,000, so the $246.40 is the amount of the interest that was earned. Again, with other compound interest problems, we will not be given a formula for interest. Instead, compute the difference between how much was put in and how much was in the account at the end. But for this problem, keep in mind that 1,000 was not the amount put in. You put in $1,000 for 3 years, so you actually put in $3,000. So this is going to be different than the problems that we did in the last section, right? You have to figure out the total amount that you put in, and in the end, we we got 3,246.40. So of course the interest is the difference between those two. Okay. So again, no formulas for interest other than simple interest. You just have to figure out how much you put in and how much you have at the end, or how much you borrowed, how much you have to pay back. Right? The difference between those two. All right, but we don't want to have to do that formula that many times. Suppose it was 10 years. We don't want to do that 10 times. But that last slide was just to show you how that's actually computed. It's still the other formula. But here is a way for us to do it all at one time. Right? So these are the same variables as before. R is the interest rate. N is the number of compound periods per year. T is time in years. P, this time is multiple. This P here stands for the multiple deposit. Okay, so how much you're investing every month, every year. So that's how you're going to determine whether to use Formula 3 or Formula 5, is you need to decide if it's multiple deposits, it's Formula 5. If it's a one-time deposit, it's Formula 3. Just watch when you punch this in the calculator. Even though the formula doesn't have parentheses around the bottom, if you want to try to enter this expression all in one time in your calculator, you're going to have put the denominator in parentheses. Okay. Determine the value of annuity. At age 25, to save for retirement, you decide to deposit $200 into an IRA at the end of each month. At the end of each month automatically tells you Formula 5 because it's annuity every month. All right. Otherwise, it's worded very similar to the problems from the last section. At an interest rate of 7.5% per year compounded monthly. How much will you have from the IRA when you retire at the age of 65? So again, we're going to write down our Formula 5, P times, and Formula 5 should be around page 109 in your notes, or it's also at the beginning of your notes, your formula sheet, or of course you can look at the last slide. This is what the formula looks like. Again, it's probably a good idea to put that in parentheses in case you want to do it all in one step in your calculator. The P is the amount deposited each month, which is $200. 1 plus R, which of course you need to change our interest rate to a decimal, so it becomes 0.075. 1 plus 0.075. Compounded monthly tells us N is 12. To the 12, and the time, the length of time invested in years. So we start depositing at age 25, and we want to know at age 65 how much we have in the account. So that is actually 40 years. So that would be your time. All right, it's going to be invested for 40 years. Watch your parentheses, because this formula has this set of brackets, which you can use parentheses on as well, and then it has this set. Okay, so it actually has two sets divided by R over N, and I'm going to put that in parentheses. Again, it doesn't look like it's in parentheses on your formula sheet, but good idea to do that. All right, as always, do the 12 times 40 first. All right, we always do this first. This should give you 480. Now, you can do this all in one step in your calculator if you want. Otherwise, you need to leave all the decimal places and only round your final answer. But if you want to, you can do the whole top and put out all the decimal places divided by, do out the bottom, 0.075 divided by 12. Keep all the decimal places and then only round your final answer. Okay, do not round in intermediate steps. But you can do this if you have the calculator I've recommended. You can do this all in one step in your calculator. Just remember, make sure that you count that you have the same number of forward parentheses as backward parentheses. There's not a bracket on the calculator, you just use parentheses. So you have parenthesis, parenthesis, 1 plus 0.075 divided by 12. And remember that divided by is just the division sign, raised to the 480 minus 1, close the parentheses. So this set right here is the orange bracket above. So just make sure that you have the same number of forward or backward. That's the numerator. Then you can hit divided by. You can do it all in one step, provided you put the denominator in parentheses. If you don't put the denominator in parentheses, you're going to get the wrong answer. So you hit divided by, and then the bottom is in parentheses. So for this annuity, you're going to have this 3 sets of parentheses if you do it all in one step. So you should try that in your calculator. Otherwise, remember, you can do the 0.075 divided by 12 equals plus 1 equals, raise it to the 480 equals, minus 1 equals, then times it by the 200 out front equals, and that would be your whole numerator. Then you would hit 0.07 divided by 12 equals, and keep all that, and then punch in that divided by that. 200 parenthesis parenthesis 1 plus 0.075 divided by 12, close the parenthesis. If you miss parentheses, you're going to get an incorrect answer, so be sure that you have them in the right places. Okay, so I get 604,764.4348, so it's 43. So you should be getting something, you should be getting that. If you're not getting that, you're off $1 or something. You've rounded too much in your intermediate steps. You need to keep all your decimal places. So that seems like a lot of money, but keep in mind that we've invested not $200 period, but $200 every month for 40 years. Okay? So down at the bottom, find the interest. Again, we need to figure out how much we put in and then how much we have at the end and find the difference. But we put in not $200, but $200 every month. All right, so you would multiply that by 12 to get how much you put in for the year, and then you multiply that by 40 for 40 years. All right. 200 times 12 will give you the amount per year, and then times it by 40 for 40 years. So 200 times 12 times 40. Again, there's no formulas for this. You just have to think about it. So 96,000 is how much you put in. All right. So now we want to figure out the interest, right? We figure out the difference between how much we put in and how much we had at the end. 604,764.43 minus 96,000. Always the difference between those two things. 604,764.43 is 508,764.43. And it didn't tell us where to round. You could potentially round to the nearest dollar or something like that, but I don't see it indicated. But it will tell you in MyLabs Plus how to round. Here are some calculator hints that I've already just discussed. Right, here are the steps in the TI-30X11S, which I've already discussed, here's some other information. Right, if you tend to forget parentheses around the denominator, to do it out first, but keep all the decimal places down there. You can read through that slide. Planning the future value of annuity. So the other formula was the solve for A, so we were finding the amount at the end of a specific time. This one's figuring out how much that you would have to deposit each time period to get a certain amount. So this time we will be given the ending amount and asked to figure out how much we need to deposit each time period. Okay, so this is formula. This is number 6. Right, number 5 finds A for a given P. This one finds P for a given A. You would like to have $20,000 to use as a down payment for a home in 5 years by making regular end-of-the-month deposits and annuities that pay 6% compounded monthly. How much should you deposit each month? Round to the nearest dollar. How much you should deposit each month tells you that you're trying to find your P. You would like to have $20,000 at the end of the time period, so we know that's our A. As a down payment in 5 years, so we know our time is 5. End of the month deposits, compounded monthly, again, N equals 12, which is the most common one, right? Because if you pay your car payment monthly, that's actually monthly compound interest. So that's the most frequent, or the most common. And 6%, so we're going to divide that by 100 to get 0.06. So since this time we're looking for P, we're going to go to the P equals formula. That's on the last slide, or formula number 6. So plug on in 20,000. Parentheses 0.06 divided by 12 divided by bracket 1 plus 0.06 divided by 12 to the 12 times 5 minus 1. Again, just plugging in the letters. As always, do the 12 times 5 first to get 60. And again, we can punch this in just like it is if we keep all the parentheses. So if you punch it in 20,000 times 0.06 divided by 12, parentheses, divided by, and then for the denominator, again, you need this set and the set in between, but we only have parentheses on the calculator. So it's parentheses, parentheses. 1 plus 0.06 divided by 12, close the parenthesis, raise it to the 60, minus 1, close the parenthesis. Again, if you need to pause the recording to catch up, you can. Hopefully everybody's beginning to feel very comfortable with the calculator. So this one does tell us to round to the nearest dollar. I got 286.65, so I am going to round that to 287. So that is the monthly payment. How much of the $20,000 down payment comes from deposit and how much comes from interest? So again, we just need to figure out how much we put in and subtract that from the $20,000. So our monthly payment was $287, but we put that in every month. All right, so if we multiply by 12, that will give us the amount in a year, and then we put it in for 5 years. All right. 287 times 12 times 5. So we put in $17,220. All right, so we just find the difference again. $20,000 minus 17,220. That should give you what? 2,780. All right, so we actually put in 17,220 of our own money. We earned 2,780 in interest, right? So that the total amount that we have at the end of the time is $20,000. This is just some more calculator hints about this particular formula, the P equals formula. All right, you don't need these set of parentheses here if you do the NT first. All right, and I put in there exactly what I wrote down on the previous page. All right, all the other ones you have to follow the order of operations and keep all decimal places when you're writing it down. When depositing money into a bank account, you are making a cash investment. The account's interest rate guarantees a certain percent increase in your investment, and that's called its return. Other kinds of investments that are riskier are called stocks and bonds. Investors purchase stock, shares of ownership in a company. For example, if the company has issued a total of 1 million shares and an investor owns 20,000 of these shares, the investor actually owns 2% because 20,000 out of a million, right? If you divide that out, you'll get 0.02, which is 2%. So an investor who owns some percentage of the company is a shareholder. Buying or selling stocks is referred to as trading. Stocks are traded on a stock exchange. There are two ways to make money by investing in stock. You can sell your shares for more money than you paid for them, in which case you have a capital gain on the sale of the stock, right? But you could certainly lose as well, but we're talking about just there's two ways to make money. The second thing is that while you own the stock, the company distributes all or part of its profit to shareholders as dividends. So you might be paid dividends while owning the stock, or you could sell the stock, and that's capital gain. Bonds. In order to raise money and dilute the ownership of current stockholders, companies sell bonds. People who buy a bond are lending money to the company from which they buy the bond. Bonds are a commitment from the company to pay the price an investor pays for the bond at the time it was purchased, called the face value, along with the interest payments at a given rate. Right? You hear often, like, even savings bond, you know, you buy it for $25 and in 10 years it's worth $50, and you can go trade in your savings bond and get $50. Retirement savings, stashing cash, and making taxes less taxing. You can use regular savings and investment accounts to save for retirement. There are also a variety of accounts designed specifically for retirement savings. We talked a little bit about this. A traditional individual retirement account, an IRA, is a savings plan that allows you to set aside money for retirement, up to $5,500 per year for people under 50 and $6,500 per year for people 50 or older. You do not pay taxes on the money you deposit into the IRA, right? So we talked about this before when we talked about income tax. So this is, right, before you pull, this money is taken out before you are taxed on it. You can start withdrawing from your IRA when you are 59.5 years old, and the withdrawals are then taxed, right? So you don't pay taxes initially, but you pay taxes when you take the money out at retirement. A Roth IRA is a little bit different. It's a type of IRA with slightly different tax benefits. You pay taxes on the money you deposit into the IRA up front, but you can withdraw your earnings tax-free when you are 59.5 years old. Although your contributions are not tax deductible, your earnings are never taxed even after withdrawal. So, all right, this one you pay taxes up front. All right. Employer-sponsored retirement plans include a 401k and 403b plans are set up by the employer who often makes some contribution to the plan on your behalf. These plans are not offered by all employers and are used to attract high-quality employees. So that is the end of this section, 8.5.